for joining us today, and I will hand over to Rob.
Thank you, Bernard. Yes, so hello everybody. Thank you for coming to our event. What we wanted to do, what we've been looking at doing is fundamentally risk assessing mists from metalworking fluids. Now, over the last few years, it's been very busy with the HSE. So long story short, I've got a small presentation that I'm going to go through with you, and I'm going to explain some bits and the techniques that we've used that have appeased the HSE, that the HSE have been happy with and responding quite positively to. What we done. So long story short, the HSE over the last couple of years have been conducting spontaneous inspections in organisations to review how they are managing the risk of occupational lung disease. And the two areas in which they've been looking at is wild fume and coolant mist, which I'll show in the presentation. Now, from this meeting with the HSE, wild fumes seem to be quite self-explanatory, looking at on-torch extraction, looking at push-pull systems, looking at air monitoring and air quality, and obviously the huge part that occupational health has for the welders. Whereas with the metalworking fluid, it seemed a little bit more ambiguous, which I'll go through. So I prepared a short presentation to have a look at. Obviously, any Q&A, but how I want to just start this is by saying I'm a health and safety advisor. I don't work for a metalworking fluid organization. You know, if you again ask me about the differences between synthetic, semi-synthetic, then I would refer to your supplier. I would say speak to your supplier, ask them for the differences between that. But for me, from a health and safety point of view, this has been around risk assessing, looking at the levels of exposure, looking at the occupational health hazard that metalworking fluid mist has for the operators. Okay, so if I share my screen. Okie dokie. From the beginning. So we are looking at metalworking fluid. So the risk assessment of exposure of metalworking fluid. Now, I've put this together. I'm not in really the mindset of just reading things out loud. This is more as a prompt for me for make sure that I'm covering the bits that we need to cover. But looking at metalworking fluids and looking at the types. So obviously what the main focus when it's come to whitewater, when it's come to these mists from metalworking fluid, has come from CNC operation. So looking at the running speed of your CNC machines and looking at what the levels of controls are for that, whether it be a filter mist unit or what some of the things that I'll go into. But just giving a very brief overview of metalworking fluid and what it's used for. So it's obviously used for cooling, and it's used for lubricating as well, chip removal and corrosion prevention. So this is fundamentally, as a majority of people will know, probably more so than me, what the purposes of using these metalworking fluids within these machines. Now, as I've said, there are a few different kinds of metalworking fluids which organisations have used, and during our time of working with HSE and working with the organisations which my company, North Staffs Engineering Group Training Association, work with, they've been asking the differences of level of control dependent on the metalworking fluid which they're using. Again, I would say speak to your supplier. Your supplier is going to have that information there. But just looking at some of the different types of water-soluble fluids, we've got neat oils and we've got synthetic, so obviously man-made coolants as well. Now, as I've said, with the HSE, so they had a drive, quote unquote drive. So they had a drive which started in 2021. It continues now. As you will all be aware, the HSE quite often will pick their subjects, will pick their areas which they will conduct their inspections to review what kind of controls are in place for particular hazards. At the minute, they're looking at manual handling and noise and asbestos controls and occupational health. Whereas over from 2021 all the way up to 2023, they were looking at occupational lung disease and looking at engineering and manufacturing, as I've already kind of said, is that they were looking at welding operations, so weld fume, the different kinds of controls that were in place. Weld fume, I won't spend a great deal of time on that because it's obviously catered around metalworking fluids, but obviously from the emergency bulletin that they had with mild steel and such, we knew that there was going to be a huge drive when it comes to controls for weld fume. So they want to see things like on-torch extraction. They want to see how organizations are controlling these hazards. So hazards from welding fume, as you would know, occupational asthma, metal fume fever, and the nasty one, which is lung and can be linked with kidney disease as well, or kidney cancer. Mists from the CNC machining. So with your metalworking fluids, they were looking at skin contact. So obviously dermatitis. They were looking at lung disease from inhalation. And one of the main hazards from inhalation for that was occupational asthma. So looking at organizations' risk assessments when they were risk assessing the exposure of metalworking fluids, a lot of the times, and where enforcement has actually played a part for their risk assessments not to be deemed suitable and sufficient, is they've deemed as that the exposure of metalworking fluid mists is a respiratory irritant, where the risk assessments really should specify that it can cause occupational asthma, and without that, their risk assessments weren't suitable or sufficient. So weld fume, as I've said, I've listed a few of the different kinds of controls that they were looking for. This is taken directly from HSE guidance, as you'd expect. So the movable capture hoods on torch extraction, extraction fixed to jibs and rigs and such as well. The cost risk assessments identifying the exposure limits for your weld fume. So we know the 0.5 milligrams per cubic meter when it comes to your chromium and 0.05 milligrams per cubic meter when it comes to your magnesium and things like that. What form of respiratory equipment that the operator is wearing to make sure that it's suitably controlling the risk of exposure to the weld fume, as well as the extraction. Now, the interesting thing is looking through these guidance documents through the HSE Cost Essentials, which I've got at the end of the presentation. And if anybody wanted links to them, they're all on the HSE website, but we're sure we could find a way of sending the information over to you. Is they were looking at excessive welding, and what the HSE would deem to be excessive welding would be anything more than an hour a day. So anything more than an hour a day would need like a full scope of all these controls listed here. And then in-house maintenance, checking your LEVs working correctly, making sure that people are complying to the requirements in the workplace. Now, with the metalworking fluids, they're looking at filter mist units for your CNC machine. So if we've got some form of extraction on there to quickly rid the machines of any mists, or if we haven't got that, dwell times. Now, this is where obviously a lot of the companies that we've been working with, that's a big no-no. We don't want to have dwell times on the machines. We need to keep the machines running because we're a production company. And anecdotal evidence from the HSE will say that the dwell time, the programmed dwell time, so meaning that we cannot open these doors, can be anywhere between 10 minutes and 30 minutes to allow the mist to settle. So obviously that's a bit of a red flag for a lot of production companies. In-house monitoring, weekly inspections for our pH concentration and bacteria levels, again taken from the Cost Essentials from MW0 up to MW5 for managing and controlling our metalworking fluid mist, and tools to reduce the exposure. So whether we've got swarf hooks, shovels, vacuums, something that we can limit actually physically touching this, which obviously increases the risk of dermatitis because we've got our hands covered in these oils and such. And restricting airflow. Again, this one hasn't been met with a huge positive response from dealing with this in-house at companies, but restricting airflow. So from my knowledge, we haven't got any fixed legislation in the UK to say what our pressure should be. But again, taken from what HSE have looking at and what they've been advising companies on is looking at European legislation when it comes to air pressure from your guns, from your for clearing and such. And what they were suggesting is they should be regulated down to 2.1 bar, which is 30 psi, which isn't much, but it has a huge dramatic impact on the level of mists which are kicked up in the air. And then PPE, hierarchy control, last line of defense, personal protective equipment, natural gloves for handling and such, something that's easily going to be tearing. During my meeting with the HSE, and they were heavily, suggesting natural gloves. It was a little bit kind of gloves, rotating parts, health and safety no, but they were looking at things that can easily tear, but obviously looking to reduce the risk of exposure to these liquids on the hand, which is going to cause dermatitis, which I don't know if anybody's ever suffered with that, or if anybody knows anybody who suffered with that, but it's very, very nasty. It's drying and cracking at the skin, and obviously, as we'd all know, would be riddle reportable as well. So, as I said, I keep linking back to well fume because they both fall into a similar bracket. So I've just listed some of the exposure limits for some of the elements when we look at well fume. Now, the interesting thing, and the thing that was a bit of an eye opener when it comes to eye water, when it comes to metalworking fluid mists, is the fact that since 2003 there is no registered exposure limit. So again, as I'll keep saying during meetings with the enforcement authorities and such, it was quite simple. Okay, how do we monitor the exposure limit to make sure that operators aren't exposed? Oh, we'll get some air quality testing done. We'll have somebody come in. We'll do some air readings. We'll get a formal assessment. We'll work out what the WEL is. Make sure that the operators aren't working to that. Happy days. And the inspectors will basically save you money because there's nothing to measure to. Through the EH40 document, there is no registered exposure limit when it comes to mist generated from with metalworking fluids, which makes it quite difficult. So it's a case of, from risk assessing, how do we monitor, how do we know how much is too much, how much is not enough, so and so on. So what can we use to monitor that? And this is where the advice comes in, and this is where it really took off for us in a way, is what the HSE suggested is use a torch, use a light. So that's what we did. So we have used a dust lamp across all of Staffordshire in multiple organisations. Basically, what we've done is we've run machines which aren't suitably controlled, or there's questions of the level of control, should I say, for these machines, and we've run them at different speeds, and we have opened the doors and we have shone a torch. And what that has done is give us some form of qualitative assessment of how much mist is actually in the air. Now, the different equipment that you can use, and again, there's guidances following the HSE website on dust lamp usage and the kind of things that you can use, and this is taken directly from that. Again, there's a reference point at the end of the presentation. But battery-powered lamps, that's what we've been using. So the battery-powered lamps are convenient and easy to handle, so we can assess multiple machines. If we have been looking at an organisation with 30, 40, 50 machines, we picked the biggest one. We picked the biggest one, and we've picked the smallest one, and we've assessed them all at different speeds to calculate or to work out the levels of exposure. Most battery-powered lamps produce a narrow beam with a high-intensity light based to use a halo effect, basically, and limited area illuminated is not usually a problem, as the lamp can be readily panned and used. So what we've done, which I'll show you in another slide or two, is we will run the machine, we will shine the torch across the breathing zones, And from the torch with the black backdrop, you can work out how much mist is actually in the air. And because it's portable, we can shine the torch inside the machine and we can look at how much mist is actually inside the machine. So if the operator is getting into the machine for setting or for moving any components out, we can calculate the levels of exposure they're going to be exposed to for the dermatitis risk. Breathing zones, for me, the most important out of everything. We want to see if operators are breathing anything in. We want to see how much, if they are, and what level of control is needed, whether that's a cost-effective approach of dwell time in the interim and then putting filter mist units on there long term or whatever. And then the mains operated lamps as well, which obviously they're going to be probably a bit more reliable, but at the same time can be challenging when it comes to being movable and such. So as I've said, the benefits of using the lamp, the lamp. So fine dust and mists are invisible in normal lighting, so it makes it more visible. So the dust lamp shows exactly what's in the air. It has actually been used as well. We have actually used it to review the efficiency of the extraction that's being used when it comes to welding operations, see how much residual mists or residual fumes are being left into the environment, which has been really useful. The dust lamp should be set to observe forward scattering of the light and point the lamp to shine through. Think of a dust cloud if possible, and the background lighting would be turned off in the workshop. So the less lighting in the workshop, obviously, the more it's going to be more visible, which is useful. Note the statement in the spread of the contaminant. Check the airflow and the indicators in the extraction system. So if you did use filter mist and you wanted to see what a clearance time is, you could use it for that. Check the damage for any leakage or processes, and check the operators are encouraged and reporting any defects. Massively important. Again, for me, from a health and safety point of view, getting the operators on side, speaking to the machinists, asking them day-to-day operations, how does it work for you? Do you find that there tends to be more mists when operating different when cutting different materials or when running at different speeds? The speed things is quite interesting. So again, what HSE were looking at when it comes to CNC operation was high speed running machines. So they're looking at anything above 2000 RPM. So if you had and they didn't categorize the machines, it wasn't a lathe, it wasn't a milling machine or whatever, it's just literally CNC machine and anything running over 2000 RPM. Now I can tell you for a fact from doing multiple of these risk assessments, the speed doesn't play that big of a part in it. I've had machines running at 12,000 RPM and had little to no mist, and I've had lathes running at 300 and he's been booting it out. So the 2000 RPM, yeah, it's subjective. It's all subjective, to be fair, but as I say, the lathes, as we've had them running at very low speeds, and we've had a lot of mist coming out at them, and it's been the first point of call is we need to get them controlled. So the practical sides of using it and using the torch. So we have a black backdrop. So we will usually, it's ideal if we've got somebody else to work with us. So we will have our torch and we will have a black backdrop, somebody holding a card or something to shine the torch to. And then from that, you can see obviously the beam of light to the black backdrop, and you can see the water droplets in the air. Establish if the machine has a frequent running speed. So again, operator involvement, speaking to them and saying, you know, is there a frequency? Do you run this machine at this speed all day, every day? Which again, I can tell you is very, very rare. Very rare. It's usually no. It all depends on the job and so on and so on. Run the machine at different speeds, running the coolant through and aiming it at the spindle. So we started at the slowest speed, in which the operator would usually say they could be cutting at. So it could be anything from 800 all the way up to 2000. So we'll start at slow, and then we'll continue to go up. And obviously, you can find as the higher the speed, the more mist will come out. But again, it's all dependent on the machine. But we want to try and get an idea, because we might say, okay, at 2000 RPM, there's very little mist, whereas at 8000 RPM, that's where we need the control. So we cannot use this machine at that speed, at that frequency. Test around the machine to hatches, doors and openings for mists. So yeah, so when the machine is running and it's fully enclosed, checking around anything to make sure that there's nothing leaking out. The light is really, really useful for that. Just shine. It's really basic stuff. It's literally just shining the torch at the hatches and at the doors and such. Just make sure that there's no little residuals that are coming through the machine, which again poses a risk to the operator. Shine the torch at the machine and evaluate the risk of skin contact, which I've already said. So once the doors are open, once you've looked at that, we would shine the torch inside the machine, see how much residual mist is in the air or inside the machine, and calculate the level of risk for skin contact. And ensure that photographs are taken. So it's really useful because this is very subjective. And because there is no exposure limit, when speaking to HSE, and it was a case of, well, if there's no exposure limit, how much is too much? And the inspector said, reasonably practicable. So because it's reasonably practicable, it's very subjective. That's why, to be honest with you, from an all staffs engineering group perspective, we've got a lot of work because it's really valued an independent view. Which companies have appreciated. So it's looking at it and saying how much is too much. I would say if you are doing this, it's dependent on the assessor, and it's looking at what you determine to be is too much, and you will know. You will know from an occupational health perspective, from a health and safety point of view. You shine the torch in. If it looks like fine little particles of dust in the air, you would say, all right, the level of exposure is probably minimal. Whereas if you can shine the torch and you can see the light moving in the actual liquid, in the actual mist, you will know that the levels of exposure are to a high level, and we really do need to have some form of extraction or another control to the machine. So some pictures here for look at to the angles, so you can see where the light would be situated. Let's look at the shield there. Look at where the operator would be standing and the eye contact. From that, he generates some ideas. And here is just a quick photograph of a very early one that we did. And as you can see from that, you can see that there's a lot of mist that's coming out once the machine's being run, and filter mists were put on this machine. This was from a spontaneous visit from HSE, and they wanted to see some form of risk assessment. So myself and the manager of this particular site conducted the risk assessment, and we got it controlled. But yeah, these are the angles. Again, this is all taken. The reference point there is at the bottom of the screen, as where these photographs have been taken from. Which I'm sure we could either supply, or if you wanted to contact us, we can forward them on. But they all are available from HSE. So findings. So what we've tend to found over the years of been doing this now is categorizing machinery exclusively to CNC does not generate the same results across all machines. So as I've said, it doesn't matter. It's CNC is quite a broad term, CNC machine. So we have had lathes running, we've had milling machines, machine centers, and all of them have generated all different kinds of results. In some milling machines where we've looked at it and thought we're guaranteed that there's going to be a lot of mist from that, and it's been very minimal. Whereas ones where we thought, oh well, they've got a filter mist unit on, we'll test it, but they've got a filter mist unit on, and it's turned out as the scope and the size of the machine, we've needed another. So it's really useful as a monitoring exercise just to and it's really cost effective as well. I mean, I think the lamp was I forget, a couple £100, but it's a good in-house monitoring tool when it comes to your mists. So running the speeds at 2000 RPM does not generate mists, as I've already said. Results can be subjective, so an independent review does help, as I've said as well. And the terms suitable and sufficient risk assessment, so occupational asthma for the metalworking fluid mists. Again, which I've already said, is that the devil's in the detail with your risk assessments, and the HSE are quite rightly scrutinising risk assessments and making sure that the right information is in there, because they should be discussed, they should be briefed out. They're a living, breathing document. They're not a static paperwork exercise. Continue to review, so environmental factors can play a part. So yes, we have found that as well, as if we've had machines in quite enclosed environments, then obviously that's going to keep these mists inside, which is obviously going to increase the risk of the mists to the operator. So having plenty of natural ventilation, if we can, obviously we could be limited with that, but if we can, having natural ventilation is obviously going to reduce the risk of a build-up of these mists within the area. And finally, speak to your supplier. Your supplier is going to supply you with the material safety data sheets, any of your substances that you're using. We need to work out if there is workplace exposure limits, what they are, and how we can reduce that. Obviously, with metalworking fluids, there is none, as we said. So we need to just make sure is that what we're using, we have the right controls in place for. And here are our references. Honestly, informally, from one health and safety person to another, the HSE website has been so helpful. And I say quite regularly when I'm training, the information is there. It's readily available to us, and it's provided free of charge. It's just making sure we know where to look. And the cost essentials from the HSE has been invaluable when it's come to the metalworking controls and the welding controls as well, looking at what them inspectors are looking at. But more importantly, what are we doing to reduce the risk of our staff being made ill by what they do to pay the mortgage? Because obviously at the end of the day, that's what we do. That's our job. EH40, which we'll all be well versed in, and obviously risk assessment management. It's very, very brief. That it's been a lot of work involved with that, but that's really where we're at. It's a case of using it at different speeds, looking at your machines, running them, assessing them, and then just looking at the levels of controls which are needed. And as I say, if the mists are high, then it's dwell time, unfortunately, which nobody really wants. And especially when we're talking between 10 minutes and half an hour from a production company, that is just not acceptable. We can't do that. And alternatively to that, it's having our extraction, whether it be a filter mist or a similar kind of extraction system in place. And that is.
Thank you, Rob.
Me.
Very informative. Thank you for presenting. Sue, do we have any questions at this stage to Rob before we hand over to Wendy?
No, we don't. Rob, you must have answered everybody's questions already, because there's nothing in the chat box.
Yeah.
Okay, perfect. Brilliant. Good to know.
Good.
Thank you.
Oh, we've got one.
Oh, we've just got one. Right, Rob, are you ready? You explained the three main groups of fluids and the functional benefits. Any hierarchy of preference from the health and safety point of view? And did you conduct your survey using different fluids?
Yeah, so the surveys have been done with multiple fluids. There's been multiple organizations, multiple different kinds of machines with multiple fluids, and it's all been categorized and grouped into the same. I am not aware of any forms of control that needs to be any different form of control that needs for different kinds of metalworking fluids, whether it's synthetic, semi-synthetic, or what. As I say, what I would say if you have got questions on that is speak to your supplier. But from my experiences working with HSE on this, they have not said, well, if it's this form of metalworking fluid, we don't need it. It's been quite broad. Hope that answers that question.
Hopefully it does for Ian. And then Juliet has asked, will your slides be available to be sent out?
I'm happy to send them. Not a problem at all. Not a problem at all.
Yeah. So we usually get the slides as PDF and share on LinkedIn. I will speak to IOSH as well if they can share it as with their participants afterwards via email. So thanks for sharing, Rob, as well.
Okay.
There's one more question, Rob. Could you just explain what dwell time is?
Okay, so dwell, apologies if I didn't explain that very well. So a dwell time is where the machine has to be programmed as that you physically cannot open the doors. So you might run your cycle time, and usually what will happen is the doors will be open, and you can get straight at it. And obviously for production companies, as soon as it's finished, they want to be back in. They want to open the machine, unload, and load again. So what a dwell time is that you program the machine so the doors cannot be opened. And as I say, that can be from 10 minutes to half an hour to allow the mists to settle inside the machine, which puts the fear of God up a lot of people, to be honest.
Thanks, Rob. I think that's it.
Yeah. Perfect. So thank you very much. And then Wendy, I will hand over to you. Yeah.
Okay, I'll share my screen then.
Thank you.
Okay. Okay, so my name is Wendy Gould. I'm the General Manager at Phoenix Occupational Health. I've been an OH nurse for about 19 years now, worked for Phoenix for the last 4.5 years. So I'm going to talk overview of occupational lung diseases, and then a bit more specifically about their effect in metalworking fluids. Okay, so
Sorry, Wendy, we can see your speaker notes as well, not the pure slideshow.
you can't see the slideshow. Oh, this is how rubbish I am, you see, at doing these things.
No problem. Just we'll give you a few seconds.
To be fair, there's no speaker notes, so you're okay.
Yeah, that's fine then. Let's go then.
Except it's not moving, is it? But you know what? I'm going to go back out and just do it like this, because it's probably easier like this, and I can see you, because that was very... I couldn't see any of you guys, and I was just like looking at a screen, which is not good. And it doesn't matter, because there is no notes. It's in my head.
Yep,
and on
perfect.
here. Okay, so occupational lung diseases. These are diseases that affect the lungs, and they can be caused by something you use at work or made worse by something you use at work. And there is a difference. So you can become sensitized to something, which is a causative issue, and then if you've already got existing lung diseases, they can be irritated and affected by what you're exposed to. And this is related to breathing in, obviously, dust, gases, fumes, and vapours, and obviously metalworking fluids being a vapour or a gas. Okay, so occupational lung diseases are things like occupational asthma, which Rob mentioned earlier, and obviously metalworking fluids can result in occupational asthma. COPD, which is chronic obstructive pulmonary disease, certain respiratory cancers, lung cancer, mesothelioma, the pneumoconiosis, so silicosis, asbestosis, coal workers, pneumoconiosis, and byssinosis. Byssinosis is cotton. Pleural thickening and pleural plaques are you can get these and not develop mesothelioma, but quite often they're a precursor. And then the allergic alveolitis, which is also hypersensitive pneumonitis. Again, that can be caused by metalworking fluids. So occupational lung diseases are very serious conditions. They affect a lot of individuals at work, and they can cause substantial disability, inability to go to work, and often early death. The statistics on the HSE, 12,000 occupational lung disease deaths each year. This is from 2023. And this is caused or made worse by work. This is like self-declaration on the death certificates. There is approximately 19,000 new cases each year of occupational lung disease among those who have worked in the previous year. There are 43,000 new or long-standing cases and 152,000 new or long-standing cases amongst those people who've ever worked. So anybody who's ever worked, basically the high amount of occupational lung diseases. In the UK, the estimated annual deaths are 34% related to chronic obstructive pulmonary disease, Mesothelioma is about 20%. Asbestos-related cancers, 20%. Non-asbestos related cancers, 24%, and other diseases like pneumoconiosis and allergic alveolitis is about 3%. So you can see from that there's an awful lot of lung disease that can be attributed to the working conditions that people are in, the things that people are exposed to at work. And so obviously as employers and occupational health, we need to make sure we're protecting their health. So metalworking fluids, it's inhalation of mists, vapours and aerosols from the metalworking fluids in the machines. Also, as Rob said, it can cause dermatitis, so contact with uncovered skin, particularly the hands and the forearms. The metalworking fluid can get in open cuts and abrasions, and actually they can ingest it if the poor hand hygiene, working in the work area, eating in the work areas, not washing the hands, they're ingesting those fluids. And quite often with metalworking fluids, they can get bacteria in, and that can cause a lot of problems. And it's not just the mists, it's the bacteria present in those metalworking fluids that can cause issues. Excuse me. Okay, so we get skin disorders and lung diseases. Obviously, we're going to quickly go over lung diseases, but you do need to be aware that it can cause dermatitis. And as Rob said earlier, that is not a pleasant condition. It can really, really impact you, your ability to do normal activity or work. Okay, so anybody exposed to metalworking fluids potentially have an increased risk of developing occupational asthma, bronchitis. It can cause irritation of the respiratory tract, including the nose, the throat. It can affect the eyes. It can cause a condition called extrinsic allergic alveolitis or hypersensitivity pneumonitis. That's related to the bacteria in the if there's bacteria in the metalworking fluid, because it's not changed regularly or you don't add the antibacterial solutions to it, then it can cause that. And just general breathing difficulty, shortness of breath at work. Okay, I'm just going to go over two of the main ones. So occupational asthma is the main one that maybe lots of people know about. It's caused by sensitization. You become allergic to a product. And once you are sensitized to a product, then it's very easy to develop asthma symptoms after that, because once sensitization occurs, you're going to have asthma symptoms even for very low exposure. So about 9 to 15% of asthma in adults is thought to be related to work, which is a lot. Lots of people have asthma. With work-related asthma, with occupational asthma, the pattern is that they tend to be unwell after work. They tend to get worse after work. So after they finish work, at the weekends, and sort of on holidays, and it usually starts to then get better over a holiday, and it's worse at work, and it improves. It can be worse at night, but certainly over a holiday period, you find that it improves and then gets worse when they go back to work. If it's consistent, so if somebody has asthma within the workplace and it's consistent, they have attacks that are not relevant to work, and it can be worse at home, or they're on holiday and they have a chest infection, then that's unlikely to be occupational asthma. Often with occupational asthma, it is the other symptoms that we pick up first, and it's things like rhinitis, conjunctivitis, so inflammation of the nose, the eyes, sneezing, itchy eyes. They're often associated with asthma symptoms, and they often precede any asthma, any chest symptoms, and any results on the spirometry as well. So we use the questionnaire. That's the questionnaire that we use is the most important thing that we do. Your spirometry might not show it up, but they might be declaring things on that questionnaire already long before it shows up. Okay, extrinsic allergic alveolitis or hypersensitivity pneumonitis. This is a group of lung diseases that develop after exposure, and metal fluids is one of them. So it's caused by something out of the body. It's an increased reaction, and it's inflammation of the very small sacs right at the bottom of the lungs, the alveoli. And usually it's an inflammatory infectious thing. It gives them a fever, cough, shortness of breath, and they usually lose weight. It's been exposure to metalworking fluids has been responsible for workplace outbreaks of occupational lung disease in the US and the UK. One of the biggest in the UK was Powertrain, and that was in 2004. And when they looked into why lots of people had occupational asthma and hypersensitivity pneumonitis, they found it was related to the metalworking fluids, and they were just full of bacteria, and people were just being infected. So it's for health and safety, and for employers, it's monitoring the bacterial contamination. And where people are exposed to metalworking fluids, health surveillance should be undertaken, which is obviously where you get your occupational health community in. So health surveillance is a system of repeated health checks dependent on the exposure. So we do things like audiometry for hearing, we do skin checks, we do hand-on vibration, obviously we do other things. And then for lung disease, for occupational lung diseases, we use a questionnaire. So it's an annual test, and it's a questionnaire that asks lots of questions about health and exposure and any symptoms people have got at the moment. And we'll also do a spirometry test. And so there's if you can see that, that's the questionnaire that we use, and obviously that's a spirometry. So it's quite an in-depth questionnaire, and it's looking at past history, it's looking at smoking, but it's also looking at particularly things like itchy eyes, runny nose, coughing, sneezing, and when they're worse at work, and does it get better outside of work. And those are the things that will sort of raise alarm bells for us as OH practitioners. So when they have health surveillance, if there were any changes with the spirometry, or they are saying they've got symptoms that could be related to work, we would escalate those symptoms to one of our consultants. We might do things like what we call a serial peak flow. And what we do then is ask that individual to take a peak flow monitor home and take their peak flows. And we ask them to do that for 4 weeks. We ask them to do it every 2 hours throughout the day and night, and a week off work, because if it gets better over that week, we know then it's work related. If it doesn't, it's not. And that's the test. And then sometimes we can also, in occupational health, refer to specialist chest centres. There are three, I think. The Royal Brompton, Sheffield and Birmingham. These doctors at these centres accept referrals from occupational health, and a lot of their work is related to occupational lung diseases, and so they monitor those, and they can treat them and do lots of other ongoing tests to determine whether it's occupational lung disease or not. So they're a really useful resource, and we can't refer much into the NHS, unfortunately, but we can refer into them, and that's very useful from the point of view of protecting employees and getting diagnoses quick, so we can treat them and restrict them from the working practice. And that's it, really. It's quite a brief overview of occupational lung disease, if anybody's got any questions. Oh, and can I just say, Robert, I totally agree with you in the HSE. It's such a useful resource. It's the one I always use to. The first place I go to is the HSE.
Thank you, Wendy. Yeah, very informative as well. I mean, for from the IOSH perspective as well, for occupational health and safety, practitioners. So
Yeah.
Thank you very much. Sue, do we get any questions for Wendy?
Nothing come through on the chat as yet.
We'll give it a few more seconds, or somebody would like to unmute themselves just to ask direct question.
Nope, still nothing coming through. You obviously answered everything as well, Wendy.
I doubt it, but yeah, if anybody's got any questions, feel free to email.
Can I ask a question, please?
You can.
Sure.
The lung disease, like, is it I don't know how to pronounce it quite right, mesothelioma?
Mesothelioma.
Yeah. Is it actually irreversible in the real sense with medication as well?
Yeah, mesothelioma is you're not going to survive it, unfortunately. Once you've got this, it's a type of cancer specifically related to asbestos. Asbestos can cause other cancers, but it's a specific relation to asbestos exposure, and there's nothing they can do.
All right. Thank you very much. Thank you.
Wendy. Thank you. Ian Smart raised a hand.
Yeah, thanks. Wendy, you on your slide, you said that health surveillance is required by law when the worker remains exposed to health risks, even after control measures are put into place. Where does that sit with the as low as reasonably practicable? If you've got your control, if you've controlled the risks to ALARP and you've decided that there's nothing further required, is health surveillance still needed? And I'm just thinking about diesel exhaust emissions in our car parks.
Yeah,
We can't get them any lower. Do we still legally have
Yeah,
to?
because because you need, so you might have your control measures in place, but how do you know they are effective? So the whole idea, partly, obviously, health surveillance is a legal requirement anyway if there is exposure to chemicals under COSH or noise under noise-induced hearing loss or hand-arm vibration. And part of the job of doing that is that actually, if you've got good results and everybody's okay, it proves your control measures are working. It's evidencing that your control measures are working because your employees are healthy. So it's still a requirement, even if you've got it as low as is reasonably practicable.
Lovely, thanks for that.
According to HSE.
A couple of queries have come through, Wendy. Is the questionnaire available for us? Will we be able to send that round? And also, again, a copy of your slides, please.
I can send the slides, but the questionnaires are intellectual property. It's what we use, so no. Unfortunately, it is our property as part of ROH company. So there are lots of generic ones, I have to say, on the HSE, because they're fairly standard, if you like, from the point of view of what they ask. We might ask a few different things. It depends what type of area we're working in. We might tailor it to each, depends what the employees are exposed to, really.
Thank you. Nothing else has come through on the chat.
Thank you, Sue. So I think we can wrap up now. So Wendy, Rob, thank you so much for preparing and presenting at Staffordshire branch for our members. So very informative, very insightful, very practical advice, and then it's very helpful overall. So thank you.